In this activity, I'm going to show you how to make a binary counter like we have here. It's going to be just like a counter, like an odometer in your car, except that rather than being in base 10 numbers, it's going to be in binary. I'm going to assume you're all, of course, fluent in binary. I'm just kidding. Let's go back and review it. What binary is a number system based on powers of 2 instead of powers of 10. So instead of having a ones, tens, hundreds, thousands column, we're going to have a ones, twos, fours, eights column, right? So every time our place value will be multiplied by 2 rather than multiplied by 10. So that's how we're going to do this. Powers of 2 instead of powers of 10. And every time our clock ticks or our counter ticks, or anytime we want to go to the next number, what we're going to do is add 1 to the rightmost digit. And if that produces a carry, well, then we'll add 1 to the next digit. And if that produces a carry, we'll add 1 to the next digit, and so on and so on. And if eventually, if we lose the carry, if we get an overflow, we're just going to ignore that. And that's going to be like, you know, an odometer kind of rolling over because we ran out of digits to store the number. So we'll be able to watch this counter cycle through 0 up to 15, which would be 1111, or F in hex, right? And then, yeah, you know what? We'll make it 8. We'll make it 8 characters long. And then I'm going to have you modify this to turn it into a random number generator. But I'm going to walk you through how to make the binary counter part of it, and then you're going to have to figure out how to modify it to turn it into a random number generator. Now let's review the rules for binary addition. A 0 plus 0 is 0, right? That makes sense. 0 plus 1 is 1. That makes sense. 1 plus 1 is 1, 0. Well, that's not right. Yes, it is right. So what this number is a 2, right? It's a 1 in the 2's place and a 0 in the 1's place. So this 1, 0, that is a 2 in binary. So 1 plus 1 is 2, but that's what 2 looks like in binary. Now when we're doing addition, that's going to be a 0 carry the 1. Just like if we add 1 to 9, that becomes 10, but we don't write that as 10, we write that as 0 carry the 1. So this is the condition that's going to produce a carry, is when we take a bit and we add 1 to it, and if that bit was already a 1, then that bit will become a 0 and produce a carry. And then let's just review the rules for converting binary to decimal. What we're going to do is just add up the powers of 2. So the picture here is showing our powers of 2, 1, 2, 4, 8. So this number here, 1, 0, 0, 1, that is a 1 in the 1's place plus a 1 in the 8's place. So this is the number 9. So to figure out what the value of our counter is going to be, we're going to look at all the bits in our counter and multiply each bit times its place value, and then add that all up. So that's going to be a loop followed by a variable that's going to act as an accumulator that keeps a running tally of our bits multiplied by their place value, and that'll give us the final number. All right. So how are we going to model our project here? What we're going to do is we'll just create a class that represents a bit, and that class is going to have a picture box associated with it, and it's going to have a value that stores whether it's a 1 or a 0, and it's going to be that bit's job. One of the things that class will do is it will keep its picture box in sync with its value. So let's scroll back up to the top here. So this picture that you're seeing, the 1, 0, the 0, 1, 1, 1, these are picture boxes all squished close together, and each picture box is displaying an image, a GIF, or a PNG that has either a 0 or a 1 on it. So we're going to have an array of class objects. Each class object will represent a bit, and it will have an integer that stores whether it's a 0 or a 1. And it will also have a reference to its associated picture box. So it can keep the picture box, the image being displayed for that bit, in sync with the value of that particular bit. So this is going to be an array and looping exercise primarily. So let's head over to Visual Studio, and I'm going to create a new project here, and I'm going to make a Windows Form app. So this is going to be a Windows Form app .NET framework. Don't make a .NET Core. You want Windows Forms app .NET framework. I'm going to click next, And what do we want to call this thing? I'll call it, binary counter. And for the solution, let's say create a new solution, and let's give it the name, binary counter or something, week 4. I think we're in week 4. And I'll leave the .NET Framework version set to whatever it is. If you were trying to deploy this on an older machine that didn't have it, that had a different .NET Framework version, maybe you'd go back a few versions. I don't know. Usually I just leave this thing set and everything seems to be fine. And I'm going to click create. All right, so here's my form app. Maybe I'll kind of shrink this a little bit. And let me go change the text property for that form. So I'll go down here into my properties, down here at the bottom right. And I'm going to change that to binary counter by Evan. Right. So put your name up there on the title bar. And I'm going to save that. Now let's go grab the resources for this project. So you want to download the resources from Blackboard, unzip them. The only resources are just 2 images that we have to import. So to import your images, and this should be very familiar, we did this in snail races, we did this in stoplight. By the end of the semester, you'll be doing this in your sleep. We want to go to the project menu, go down to properties, resources, project properties, resources, project properties, resources, project properties, resources. Okay, there we are. Now let's go add an existing resource. Add existing file. And now I've got to go find out wherever I put my stuff. Activities, binary counter. There we go. Let's grab those. I'm going to I hit the control key there to grab both of them. And I'm going to click OK. So I have LED 1 and LED 0. Those are my 2 images. There we go. And you can see over there now in my resources, I've got a resources folder and I've got those two PNGs. All right, so let me go. What am I going to do? Let me go back to my form here. Let me bring up the toolbox and add the LEDs. View. Let's pull up our toolbox. And let me add a picture box here. Picture box. Yeah, okay. And then let me set it to the image in this thing. So what I'm going to do is I'm going to right click on that little arrow on the picture box, and I'll say choose image, and let me pick the 0 here. Click OK. And then let me auto size this thing. I'm going to say size mode, auto size. There we go. So now I have picture box 1. Now notice the picture boxes start getting numbered at 1. Array elements start getting numbered at 0. So if I'm going to try to match bits to their picture boxes, I'm going to be off by 1, and I can either adjust for that later, or I could go in here and change this to be picture box 0. I could renumber my controls starting at 0. I'm just going to live with that, and I'll do the +1 thing. I'll handle the +1 error later. So now let me just make a whole bunch of these. Control copy, or Control C, Control V, Control C, Control V, Control C, Control V. It bugs me, I can't get them right next to each other. If you actually, if you select one, you can actually use the arrow keys to kind of move them around. 1, 2, 3, 4, 5, 6, 7, 8. There we go. And now let me put some labels on top of those picture boxes so that I can, I can kind of see what place value they have. And let's see, can I get? Oh, I was looking for something up here. I think there were some controls for, yes, horizontal spacing, vertical spacing, center, and form. So there are controls up here, are options up here that allow you to position objects precisely on the form. I generally don't use these very much, but they are there if you need them. So there we go. Align the left sides, align the tops, right? Align the middles. So that can be useful if you're trying to achieve like some really nice professional grade formatting. I rarely have to do that. So now what I'm going to do is I'm just going to put the labels up there. So in my toolbox, I'm going to look for the label control. And I'm just going to drag a label here. And I'll change that to be the text for that label. I'll call that the ones. And now what I'm going to do is I'm just going to go add the rest of them, but I'm going to pause the recording so you don't have to watch that long, laborious, tedious process. So there's our picture boxes and their labels. Let me add I'm going to add another label here that's going to show the value of the number being displayed. And then let me add a text box as well to put that value in. So in my toolbox, I'm going to type in the word text, and then it's going to filter out the controls that match that. And I'll drag in a text box. And I don't want the user to be able to type in this, so I'm going to mark it read only. So that's a property down here of the text box. I'm going to set the read only property to be true. There we go. So we made the read only property true. Let me put some buttons on here as well. So let me search in my toolbox for button control, and maybe I'll make a button here that says, like, you know, next or something. There we go. And let's put a timer control on the form as well, because this will be cool if we drive it with a timer. Let's put a timer control on our form, and I'm going to double click on the timer control to create the tick event. There we go. So now we've got our event handler. Let me go back to the form here. I'm going to double click on the next button, and there's our button one click function that matches up with our binary counter. So I think we are in good shape here. So the next thing I think we want to do is make a class that represents 1 bit on this display. So that bit class is going to have an integer that represents the value it's storing, and it's going to have a reference to a picture box that is displaying the value that it is storing. So those are not the same thing. So we'll need two properties of that class. And notice I said properties. That's like a specific C# term. So let's go add a class to represent a bit here. I could do that in a separate file. Maybe I'll just do that in Form 1. So what I did was I right-clicked on the interface and I said View Code. Let's put the class down here. We could put it in Form 1 as well. I'm sorry, we could put it in its own file as well, but we can put it in here. The only stipulation is that I've noticed with a class that has a form, the form class has to be the first class. We couldn't define our bit class up here. The form has to be the first class in the file. I'm not quite sure why that is, but that seems to be the case. So let's make a class that encapsulates 1 bit in this counter. So let's make a class, and hit tab twice, and I'm going to call this bit. So now I've defined a class called bit. Let's add a constructor to our bit class. CTOR tab. There, we now have a public constructor. Maybe we'll add some parameters to that later. And what does a bit class need? Well, it needs its value and it needs a picture box. So let's add some properties to our bit here. Let's add a picture box control. Well, let's make it a property then. So prop tab. And it's not an integer. Let's make it a picture box. And we'll call it, I don't know, what do we call it? We'll call it, well, let's just call it picture box. How about that? Picture box control. How about that? That sounds good. And right now it's a get and set property. Let's also add a property that stores the value. I guess you could argue that could be a bool because it's true or false, but I'm going to make it an integer. Public. No. I'm going to let the editor write the code for me. prop tab. So we'll have an integer property. I'm just going to call it value, and And this is it's got, right now it's kind of an automatic property. It's got the getter and the setter. So now let's think about what else this bit class is going to need to do. We're probably going to want to have a function that allows us to increment the bit and tells us if there was a carry or not, probably. And we probably want to change our constructor so that it puts a 0 in the picture box. But we've got a problem though, and that's in the constructor, we don't actually have a picture box. So maybe in our constructor here, I'm going to add a picture box control. I'm going to call it PB. And I'm going to say this dot picture box control equals PB. So in our constructor for the bit, we're going to provide it the picture box that it's going to display its value in. And our value will get set to 0 by default. 0 is the default for the numeric types. It's not like C or C++ where it could be garbage unless you're building a debug version. And then, but let's also put the correct image in the picture box. So let's say pb.image equals, and then how do we get the image that we want? That's going to be properties.resources.led0. So the constructor for the picture box will set will store a reference to the control for that picture box, and it will also set it to a 0. And just for the sake of completeness, let me just set the value to be 0. Now let's add a function that adds 1 to a bit. And two things can happen when we add 1 to a bit. Either it will produce a carry or it won't produce a carry. So let's return a result that indicates whether it produced a carry or not. And let's make it a public function here. Public bool, so it'll return a true false value. And let's just call it increment. So what happens when we increment the bit? Well, we're going to add 1 to the value. If the value is 1, we're done. If the value is now 2, then we got to set it back to 0 and return true to indicate that there was a carry. So let's just handle those two cases here. So let's add 1 to value. Say value plus plus. And now let's check value. If value is equal to, now this is interesting. Okay, is equal to 1. Then let's put a 1 in the picture box. I'm just going to go up here and grab this. And we called our thing picture box control. No, picture box control. So we're going to put the 0, nope, we're going to put the 1 in the picture box, and we're going to return false because there was no carry. Now I wonder if you're seeing what I'm seeing. So otherwise, if the value was 2, that's our 0 carry the 1 scenario. So let's put the 0, that's a 0. We'll set our value back to 0. And we're going to return true to indicate that there was a carry. Now we could actually put all of this in the setter, because when we set the value to that new value, when we add 1 to it, we're setting it. So we could actually take all of this and move it into the setter for the value. That would be another valid way of doing this. And just to recap what's going on, this is our, if we add 1 to value, if value was 0, now we have a 1. So this is our 0 plus 1 scenario. And if it wasn't that, then the bit must have been a 1 to begin with. And this is our 1 plus 1 scenario, which is 0 carry the 1, which is 0 carry the 1. Those are our two scenarios there. Now what we can do is make an array of those bits in our form class. So let's go back up to our form class here. Now I guess I can put the variables, the class members down at the bottom. I can put it at the top. Let's put it at the top here. Let's make an array of those bit objects. So what's the syntax for an array? Well, first I need the type. It's a bit. And then I use the square brackets. This is different from C++ and Java. The brackets go with the type. So this is a bit array. Let's call it bits equals. Okay, now, if I were declaring an array in C or C++, I'd get a block of objects. That's not what's going on in C#. This works like Java. When I declare an array, I'm getting an array of references. And then I need to go initialize those references. So first I have to allocate the array, and then I have to go allocate each individual reference. So let me declare my array here. Equals new bit, and then how many bits are there? 8. There we go. So that should give me an array of bits. So that's a bit array called bits. It points to a new block of 8 bits. This syntax right here is just a little bit different from C++ and Java, but I like it better because it reads more like what it is. It's a bit array. I think this makes more sense than putting the array after the variable name. Now, we have a little bit of an interesting problem here. How am I going to set each one of these 8 references so that it points to the right picture box? I could do this. This is not the elegant way to do that. I could do bits sub 0 equals new bit, and then let me give it the picture box. Picture box, there's my picture box controls, picture box 1, right? I could do that, and then I could copy and paste that 7 more times. That would work. That makes my eyes want to barf, though. Let's see if we can find a better way to do that. So this works, but imagine I had a 64-bit counter or something. We wouldn't want to do that. Let's see if there's a way we can do that using a loop. So we'll loop 8 times. Now the trick comes, the question comes, how do we get a control using its name? And it turns out that there is, in fact, a way to do that. So let's go figure out how to do that. I'm going to delete all this. What I'm going to do is make a loop, a for loop that runs 8 times. If you know how many times you're going to loop, a for loop's a good choice. FOR, tab, tab. There's our for loop. Let's run 8 times. I just hit tab to jump over to the next thing. Now what I'll do is I'll say bits square bracket I. So go and set. So the first time this loop runs, I'm going to be working on bit. There we go. Bit I. First pass through this loop, I will be 0. So I'll be working on bit 0. The next pass, I will be 1. So I'll be working on bit 1. The next pass, I will be 2. So I will be applying this operation to bit 2. So bit sub I, so the ith bit, right, is equal to a new bit. Now, do I want to do this all in one go? Probably not. Let's see if there's. Let's break this up into more than one line. So the trick here is, how do I ask for a control by name? And this form class that I'm in actually has a container, it has a list of controls, and I can search that list for a control that has a particular name. The name of that list is just called controls. So let's see what's in there. Controls dot. And if I just kind of scroll through here, contains, oh look, there's a find function. Let's look at that. Find, and it takes a string and a flag that says to kind of recursively search the children, and we don't want to do that. We just want to search immediate children of this form. So we want to find a control that has the name picture box. Now, the problem is, the first pass through this loop, I is going to be 0, 1, 2, but the picture boxes start at 1. the controls started getting numbered at 1 and not 0. So we can't do like picture box plus I, because this isn't going to work. There's no picture box 0. But what we can do is just say picture box I plus 1. So this will find us a control named picture box 1 when I is 0. Wait, when I is 1, it'll try to find us picture box 2. Now, why is this barfing at us? Why is this not happy? And if you look at the IntelliSense for this find function, you will see that it returns an array of controls. It returns a control array, because there could be, maybe there's more than one control with the same name. So, although that seems like it would be a collision that would create problems, but it is returning us an array of controls. So what we need to do is we're going to assume that there's only one control with the name we want, and let's just get the first control that has that name out of the array. So we know what this is going to do is return us an array with one element. So let's do this. Picture box, I'm going to call it PB for picture box, equals controls.find. Now, this whole thing is returning us an array. So I could do square brackets 0, that would work. Or I could do dot, how about dot first? Dot first would work. But I still have a problem. What is the problem? Let's go look at the IntelliSense again. Find is returning us a control, an array of controls, but picture box is a specialized type of control. So all picture boxes are controls, but not all controls are picture boxes. So what I have to do is typecast. I've got to cast this control object to be a picture box. And we know it's a picture box because, you know, we named it. We know we're the ones that dragged the picture box control onto the form. So how do I do the typecast? Well, I could do a C++ or Java style, a C style typecast where I convert this thing to a picture box. And that should make everybody happy. Not quite sure. Oh, I forgot the second parameter there. Remember, there was that Boolean flag. Okay, so now we're happy. But that bugs me. This is like a very not C# way to do it. Remember, we have is and as at our disposal. So let's, even though this works, let's typecast it to be a picture box, as a picture box. There we go. So that's a more C# way of doing that. So what this is doing is it's finding us a control by name that returns us an array of controls. We're using the first function to get the first element out of the array, and then we're typecasting it to be a picture box. And now we can use that to create our bit. There we go. So that's you know, a little convoluted, but at least, you know, somebody looking at this code would say, okay, at least they didn't have to do the brute force thing where they manually created each bit. Now I should be able to run this and see that it doesn't crash. We should probably like disable the cursor on that. That's kind of annoying. All right, let me close that. Let me go down. I'm going to go just test that it's working down here in the constructor for the bit. I'm going to change the LED image to a 1. There we go. Okay, so we can see that it's working. You know, just poke it with a stick and see if something changes. So now let's go work on that push button function. Our button handler. Let's see if we can get this working so that when we click a button, it'll add 1 to the timer. So I guess what we want to do is add 1 to the first picture box, and if that produces a carry, add a 1 to the next picture box. And we could do that using a loop. I guess we could also do that recursively. Let's do it recursively. I'm going to make a function called increment. increment. There we go. And it'll take the position, the position, which is the index of the bit to increment. And let me put in a comment here. Increments the bit at position, at the position. There we go. So, anytime you do recursion, you have to have a base case, right? What's our base case, like where we would stop recursing? Well, either there's no carry, or, oh, I can't show you here. If we went back to the PDF, that would be, or we ran out of places, right? We're trying to carry into the 9th position. Well, we try to carry into the 8th index. If there's no 8th index, they go 0 to 7. So at that point, we wouldn't want to do anything. So let's just check for our base case first. Quit. Let's just say quit if we've run out of bits. So if the position is equal to 8, there is no position 8. They go 0, 1, 2, 3, 4, 5, 6, 7. If we're trying to carry into position 8, we're done. Return. Some people would argue it is bad to return out of the middle of the function. I would kind of agree, except that this is a small function and no one's going to have any problems figuring out what it does. All right, so now let's increment the bit. If it produces a carry, we'll increment the next bit. So let's say if bits sub position dot increment, whoops. So if we increment it and it returns true, it produced a carry. Otherwise, it didn't produce a carry and we're done. So if that's the case here, then what we want to do is add 1 to the next bit over. Add 1 to next bit to the left. So what we want to do is increment position POS plus 1. There we go. Is that it? Is it that simple? I guess it is. If we've run out of bits, we're done. Increment the bit, and if it produces a carry, increment the next bit. I guess that works. All right, and now we just need to actually call this function that we wrote. Because I always do that. I write functions and then never call them, and then I wonder, like, why doesn't it work? But the debugger will help you fix that pretty easily. So when somebody clicks a button, what do we want to do? We want to increment bit 0. We want to increment the rightmost bit. If that produces a carry, our recursion or our function will recursively, we'll call itself to try to increment the next bit over. And if that produces a carry, we will recursively try to increment the next bit over. So I was just testing it out here, and it actually works, except that I just somehow spaced out and I got a 48. There's no 48s column. Ugh, what am I doing? It's been a long day. Let me fix that. So there's our 64, and the 48s, that's the 128s. We go up by powers of 2. Everybody knows that. All right, so that's going to be, I'm just going to put the number 128 in there. There we go. All right, let's run it and watch it work. Click, 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 click. All right, let's go through that more slowly. So now we're going to add 1 to that. Now when we add 1 to this again, it's going to add 1 plus 1. That's going to be a 0, carry the 1. There we go. Now we're going to add 1 to this again. 0 plus 1 is 1. And then let's add 1 to this again. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. There we go. And this is the number 4 we have. 1 in the 4's place. There's a 5. The 4 plus a 1. There's a 6. It's a 4 plus a 2. There's a 7, which is 4 plus 2 plus 1. All right, so this actually, much to my astonishment, actually seems to work. And this will be fun if we drive it with a timer too. But what's also, when we update our, call our push button here, let's update the value that's displayed in that box underneath. And we can use a loop for that. So let's, I'm going to double click on the button to go to that function. So there's our button click function again. So after we've done all our recursive incrementing, now let's update the display, update the value displayed in base 10. All right, so how are we going to do that? Let's make an accumulator in sum equals 0. And then let's make a loop that runs 8 times through each one of our bits. 4, tab, tab. And let's loop 8 times because we have 8 bits. Now, what we have to do, let's add, we need to take our place value into effect here. So let's make another number. We'll make an integer, and we'll call it, m. No, we'll call it place for place value, and we'll start it off as 1 because we start off in the ones column. So our sum is going to be equal to itself. So that's plus equals. We could do it like this: sum equals sum plus bits sub I dot value. So that's whether the bit is a 1 or a 0. Then we have to multiply it times its place value. There you go. And we could have abbreviated that too. So, oh, and then we need to multiply our place value times 2 because we're going up by powers of 2. We could have also used like math.pow 2 to the I. That would have worked. So if we have a 1 in the first bit, that's going to be a 1 times a 1. If there's a 1 in the second bit, that's going to be a 1 times a 2. If there's a 1 in the third bit, that's going to be a 1 times a 4. Right? So place is always going to be a power of 2. And then at the end of this loop, we need to put the sum into that picture box. So let's, not the picture box, the text box 1. So let's set its text property to be equal to the sum dot toString, right? So everything in the .NET world has a toString function built into it, so we don't have to do any fancy conversions. And let's see if that works. Right, so all we're doing is just adding up our powers of 2. We're adding up our bits, but then multiplying each bit times its place value, which happens to be a power of 2. So let's run this. Let's see what it does. 1, 2, 3, 4, 5, 6. Oh my God, it works! It's amazing! Let's go add another button on here. Let's actually use our timer. So let's put a button on here. Now let's say I want to make sure those things are aligned vertically, or I could come up here and say format, align, tops. There we go. Well, I guess the tops were aligned. And I'm going to put the text, I'm going to set the text on that button to say start. So I selected that button, I came down here to the text, or the properties, and I found the text field, and I changed that to say start. And then let me double click on this. Maybe when the, okay, so let's say if the timer is on, no, timer 1 dot enabled. If it's enabled, then we'll stop. If it's not enabled, we'll go. How do we stop? Okay, so to stop the timer, we just have to disable it. Timer 1 dot stop. Timer 1 dot start. And let's say maybe when we're running, we're going to disable that button on the right, the step button. So that would be button 1 dot enabled equals false. Maybe when we stopped the timer, we re-enable the step button. All right, now, how do we actually get our timer tick to drive our display. It's actually really, really easy. So, okay, so if our timer is running, stop, turn the button on. If our timer was running, if our timer wasn't running, start. Yeah, okay, I'm pretty sure that's the right thing to do. Let's go down to our code for our timer. Let's go find that. Where's our timer tick? There we go. There's our timer tick. This is really cool. All we have to do is say button1 dot perform click. Now the interesting thing is here, can we do the perform click if the button is disabled? I guess we'll find out. Sorry, I should stop scrolling around. All right, so our timer tick is going to basically click the button automatically. Although I guess I didn't think it through. Now, if we disable the button, are we still able to click on it through using code? I don't know, we'll find out. Let's run it. Interesting. Okay, so you can't click on a disabled button. It seemed like such a good idea. But what was where's our button one click function? What does that do for? Yeah, we don't want to copy and paste all that. All right, so let's just get rid of that code to enable and disable the buttons. It seemed like a good idea. Now we should see the cycle up to 255 and then roll over. Yeah, well, we're getting there. Yep. All right, well, that took a lot longer than I thought, and I had these great hopes of, okay, now that we've got this, we'll turn it into a random number generator. Maybe I'll just do a demo of that or make that I don't know, a homework assignment or something. So let's just call that a day. Let's just say if you can make this project, you're in good shape. We'll call this the week 4 in-class activity. Follow along, zip it up, submit it. And to me through Blackboard. If you have any problems, let me know. Email me your code. I'll take a look at it. On Mondays, I will be in the Collaborate session in case anybody needs help. But that's it. So there we go. There's our binary counter. I don't know. It's so cool. I love binary. Who doesn't love binary? I know, right? But, this was also a good chance to play around with, make a class that had properties, use an array. You look at some looping constructs, look at that C# typecasting mechanism, look at how to get controls out of a form, and some other C# concepts there as well, which just eluded me. They were on the tip of my tongue. But there's some good C# knowledge to be gained from this activity. So I hope you enjoyed this. Have fun doing it. Just make this yourself, zip it up, submit it through Blackboard, and I'll make sure you get the points for it.